going on, guys? In this video we are going to see how to convert the complex number from rectangular to polar and also polar to rectangular. Now first we are going to see how to convert from rectangular to polar. First, if you watch my previous video, I have mentioned that the complex number in rectangular form will be given like this: z is equal to a plus bi format, and in polar form the complex number will be given like this: z is equal to r cosine theta plus I sine theta. Now whenever we have a complex number given in the rectangular form, we can convert that one into polar form using certain formulas. First we have to figure out r. R can be figured out using this one. R is equal to square root of a square plus b square, and the other thing we need is theta in order to convert. So to find out the theta, there's another formula. Theta is equal to tan inverse b over a. Tan inverse b over a. So in this way we can find out r and the theta. Therefore we can convert the rectangular form to polar form. Now let's look at an example. Let's say we have a number given like this. Let's say the given rectangular number is z is equal to 3 plus 3i. Now the first thing we have to find out is r, and we know that r is equal to a square plus b square. In our case a is 3, so 3 square plus b is 3, again 3 square, so 9 plus 9 18, so square root of 18. That's going to be the highest square in this one is 9, so 9 times 2 is 18. Square root of 9 times 2, square root of 9 times square root of 2, so we will get 3 root 2 as our r. This is our r. Now we have to find out the theta, and as I mentioned, to find out the theta we have to use this formula. Theta is equal to tan inverse b over a. In our case b is 3 and our a also 3, so tan inverse 3 over 3, and we get tan inverse 1, and that one is 45 degree. Tan inverse 1, and that's equal to 45 degree. And we can also figure this one like in which quadrant, because whenever you see this, whenever you convert rectangular form to polar form, you have to make sure you are in the right quadrant. To find out the right quadrant, we can draw the graph. Like we know that in a graph the real number will be in the x-axis and the imaginary numbers will be in the y-axis. In our case the real number is 3, so that's positive 3, so it's going to be somewhere here, positive 3, and the imaginary number is positive 3 as well, so it's here. So the r should be here, so it's in the first quadrant, so we don't have to worry about changing anything. We can write our final answer. Okay, so the final answer is going to be z is equal to r is 3 root 2, so 3 root 2 times cosine theta, that is cosine 45 degrees, and I sine 45 degrees, and that's our final answer. And this formula doesn't always work. We are going to see that situation, and also we are going to see that the angle when you get, you have to be careful about the quadrant you are in. Like when you have quadrant different, the angle is going to change. Now let's look at those kind of example as well. Okay, now let's look at the second one. Get rid of all these things. Let's look at the second one. Let's say we have a number given like this: z is equal to 2 minus 2 root 3 I. Okay, here we have 2 is the real number and minus 2 root 3 is the imaginary number. Now in order to find out to convert this one into polar form, we have to find out the r first. R is equal to a square plus b square. In our case a is 2 and b is negative 2 root 3, to root 3 square, and if we square both we will get this 2 square. So 2 square is 4, negative 2 square is 4 as well, and square root of 3 square is 3. So we are going to get 4 plus 12, that is 16, and higher square makes it, like 16 is a square number, so it's going to be just 4. So r is equal to 4. Now the next step we have to do is we have to find out the theta. To find out the theta, as I mentioned before, we have to use tan inverse b over a, and when we use b over a, and if you have a negative number, we can neglect the negative and find out the final answer. So tan inverse, just neglect the negative number. So this is going to be 2 root 3 is the b in our case, and 2 is the a, so 2 cancels, we get tan inverse root 3, and tan inverse root 3 is equal to 60 degree. Now we have to make sure whether it's the 60 degrees right. To check that one, what we do is we go to the graph, we graph the given complex number. If we graph this one, we know that real number will be in the x-axis and the imaginary number will be in the y-axis. Okay, so I'm going to use a different color. In our case, the real number is positive 2, so it's in the positive x-axis, and the imaginary number is negative 2 root 3i, so it's going to be in the negative axis. So we are going to have the distance somewhere here, because this is our x-axis and this one is y-axis, so the angle that's going to make is going to be right here. So the 60 degree is basically 360 minus 60, so we will get 300. So the theta in our case is actually theta reference actually 300. Theta is 300. Now let's look at the situation we can have. Now this is one case we looked at, but whenever you deal with converting a complex number to rectangular to polar form, you are going to deal with these 4 different kind of situations. This is our first quadrant, second quadrant, third quadrant, fourth quadrant, and we found out fourth quadrant and applied one method. Now let's see what happens if it's in the first quadrant. If it's in the first quadrant, we are going to have the same angle as we calculate, so theta 1 is going to be theta reference as well. But if it's in the second quadrant, what we have to do, if we get the same answer here, the 60 degree, and whatever the found out is in the second quadrant, we have to just minus that one from 180 minus theta reference. Let's say we got 60 degree, and whatever the complex number we are finding out is in the second quadrant, we have to put 180 minus 60, and that's going to be 120. Let's say we have in the third quadrant, let's say we found out a complex number somewhere here, and that's going to be 180 plus theta reference. 180 plus theta reference. Let's say we get 60 degree and we got a complex number right here, so it means 180 plus 60 is going to be 240 degree of the angle. Now in the fourth quadrant, as we have done something, so we have to just do 360 minus theta reference. That's what we did here. We minus the 60 and we got 300. So our final answer is going to be r, actually z is equal to r times, r is 4 times cosine theta, theta is 300, plus I sine theta, sine 300. And that's our conversion of this given number from rectangular to polar form. Now let's look at another example. Okay, my mouse. Okay, Now let's look at another example. Okay, now let's say we have a complex number given like this. I use white color here. Okay, let's say the complex number is given like this. Z is equal to -3 plus 5i, and we know that r is equal to square root of a square plus b square. A is -3, -3 square plus b is 5, so 5 square. So we are going to get 9 plus 25. That's going to give us 25 plus 9 is 34, square root of 34, and there's no square number we can multiply to get 34, so it remains as square root of 34. Now the next step we have to do is we have to find out the theta, and theta is equal to tan inverse b over a, tan inverse b over a, and whenever we use this formula we neglect the negative number, so this is going to be tan inverse b is 5 over a is 3, so we are going to get tan inverse 5 over 3, and if you calculate this one you will get 59 degree. Now we have to see whether it's exactly 59 degree or we have to do some change. In order to find that one out, we have to see which quadrant the given complex number is in, and here we can see we have a -3 as our real number, so it's in the negative x-axis somewhere here, and then we have 5i, that's imaginary number, so it's somewhere here. So we are in the second quadrant, and as we see in some of the formula before, whenever we have a angle in the second quadrant we have to minus that one from 180, so theta is equal to 180 minus 59, and that's equal to 121. That's our final degree. So the final answer is going to be in polar form, the given rectangular number. If you convert that one into polar form, we are going to get square root of 34, that's our r, times cosine theta, cosine 121 degree, plus I sine theta, sine 121 degree, and that's it. Now let's look at some other examples. Let's say we have given a complex number like this. I'm waiting for my mouse to respond. Okay, it's responding now. Okay, let's go. Now let's say we have a complex number in rectangular form is given like this. Z is equal to 3. Now whenever we have a complex number that has just one, like real number or imaginary number, it just take the same number, like r takes the same number, r is equal to 3. Like let's say if there's a negative number, it's going to be positive, that's the only difference. Other than that, it's going to be exactly the same number. Now let's see some of the things, like let's prove this one. The reason is, let's look at this one first. Like c is equal to 3, and it means the imaginary number is 0i, and if you put it in the form we convert r into like z into r, that is basically a square plus b square. Here a is 3 square and b is 0 square, therefore we get square root of 9, that's 3. That's how we got this 3. Okay, but the shortcut is you always remember that whenever you have just one number in a rectangular form, r take the same number, and that's it. And if we convert this one into polar form, we are going to have, let's calculate the angle, that is theta is equal to tan inverse b over a. B is 0 over 3, that's going to be tan inverse 0, that's equal to 0. Okay, the angle is 0. Now we can check it in the which quadrant. This 3 is in the positive x-axis, 1 2 3, so the real number is somewhere here. so it means this 0. But there are 4 possibilities. Like whenever we have just one number in a rectangular form, we can have 4 different angles. It can be 0 degree, it can be 90 degree, or it can be 270 degree, and it can be 360 degree. So there are 4 different answers we can get. We are going to see those kind of example. In this case, it's going to be 0 because it's in the positive x-axis, so it's going to be just 0. So the final answer is z is equal to r, that is 3, and cosine theta, cosine, the angle is 0 degree, plus I sine theta, that is sine 0 degree. Okay, now let's look at some other examples. Let's say we have this z, okay, I'm waiting for my mouse to respond. Okay, now oh my god, what just happened? Okay, I don't know what just happened, but I'm gonna just keep on going. Okay, let's try this one here. Okay, let's say we have a complex number in rectangular form given like this. Z is equal to -4. What's gonna be the r? R value is gonna be +4. That's the difference. Like when we have a negative number, the r gonna be take the positive number of that, but other than that, r take the same number as the rectangular form if it just has one number. Okay, now it means if z is -4, it means z is -4, and we don't have imaginary number, so that's 0i. That's why we got r. You can try the r is equal to square root of a square plus b square. You will get this answer. Now we have to find out the theta. Theta is equal to tan inverse b over a. So tan inverse b is what, 0 divided by 4, because we neglect the negative when we use this formula. So this is going to be just 0, tan inverse 0, that is equal to 0 degree. But this formula always doesn't work, so we have to check it in the graph. If you check it in the graph, you can see this the complex number real form is in the negative axis, like -4, so it's somewhere here. So the real number is somewhere here, and imaginary number is 0, so it doesn't matter. But since the real number is in the second quadrant, we are gonna have, if it's here it's 0 degree, if it's here 90 degree, if it's here 180 degree, if it's here 360 degree. Since it's here, it's 180 degree, so 0 degree is wrong. The answer is 180 degree. Now if we put it in the formula, like the polar form, z is equal to r, that is 4, and then cosine theta, theta is 180 degree, plus I sine theta, sine 180 degree. That's the conversion of the given rectangular form complex number into polar form. Now let's look at some other examples. Let's say I'm waiting for my mouse to respond. My mouse is a little bit laggy, I don't know what happens, I have to fix it. Okay, still not responding. Okay, now it's working. Now let's go. The next one is z is equal to -2i, and here we have just imaginary number, and it doesn't matter imaginary or real number, the r takes the same place as the same number but only positive number, so it's 2. And then if we write it in the regular form, standard form, we know that the real number is 0 since we don't have anything. 0 minus 2i. Therefore, the theta can be calculated using this formula, tan inverse b over a. In our case, b is 2. So tan inverse, this is negative 2, but we neglect the negative, over 0. 2 over 0 is going to be just 2 over 0 is just going to be 0 again, but we don't have, we even have to. So whenever you use this, like see one number, don't even try this. That's my preference. Like whenever you see one number, you can easily find it using the graph. Like negative 2, like 0 in the x-axis, so it means nothing in the x-axis, and negative 2 in the imaginary number, so it's in the negative y-axis somewhere here. So it means this is 0 degree, this is 90 degree, this one is 180 degree, and then this one is 270 degree. So the answer is theta is 270 degree. So don't even try that formula if you see one number. So the final answer for this one is going to be z is equal to r, that is 2, and then cosine theta is 270 degree, plus I sine theta sine 270 degree, and that's our final answer for this one. Now we can also see one more similar to this. Z is equal to, let's say z is equal to 5i, and here r take the same place as z, since we have just one number, that is 5, and then theta, we have to see which quadrant it is in. Since we have just one number, we can directly find out by looking at which quadrant. R is positive 5, but R is a imaginary number and positive, so it means okay, my mouse is laggy. I'm waiting for it to respond. Okay, now it's a positive 5i, so the imaginary number is going to be in the y-axis, so positive 5i mean is somewhere here. So the angle it takes is 90 degree. If it's here it's 0, if it's here 90, if it's here 180, if it's here 270, since this is in the second one, so it's going to be 90 degree. So the theta is equal to 90 degree, and in the complex talk form we write the given number like z is equal to r, that is 5, cosine theta cosine 90 degree, plus I sine theta I sine 90 degree. Okay, now we have seen all the way of converting a complex number from rectangular form to polar form. Now let's say if we have a number, complex number given in the formula polar form, we had to find out it in the rectangular form. Now let's look at an example like that. Let's say we have a complex number given like this. Z is equal to 4 cosine 90 degree plus I sine 90 degree. Now this is in the polar form. Now if we convert this one to rectangular form, what we have to do is we have to just simplify. 4 cosine 90 is 0, and then sine 90 is just 1. Therefore we are going to get 4 times 0, that is 0, 4 times I, that's going to be just 4i. That's our final answer. Z is equal to 4i. That's the rectangular form of the given polar form. And we are going to see more of these kind of things in my next video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.